Awesome. Turn on the transcription also, no? It helps us prepare the notes then. Okay. You guys remember him? Yeah, of course. Okay. Now, the hero, yes. Okay. So I have a surprise for you guys, okay? Something very interesting. Something that will blow your mind in a way. Events by? That's a secret. Anyone wants to guess what the secret is? It's very interesting. He's still a O, zero. No, hey, don't say, man. It's sweet. Guys, look at his face. He's ready. He's ready. Yeah, rude. Hey, Hafsa, damn. You're right. He has a girlfriend. Spot on. Evans Boy has a girlfriend. Damn, he has a better love life than us. I mean, y'all. I'm good. Interspecies relationship. Hey, we don't judge, okay? हम ऐसा भेदभाव नहीं करते. भाव. Damn. We don't judge that way. It's okay. He is free to love who he wants. Yeah, exactly. Happy for him. So her name is Deviant's Behan. Now she's not his Behan, she's our Behan, okay? Or other Bhabhi if you so any other name. No. Deviant's Behan is nice. But she's our Bhabhi. Okay. So what is Deviant's by? Is the value minus mean. She is value that is of some other thing and the mean. Now they're a good happy couple. Sometimes they agree on things, they go on sweet dates and stuff. Sometimes they argue about things. Sometimes they have their differences. Okay, they do not always agree about everything. Okay, but they're a good couple. They're a happy couple. They're doing pretty well. Sometimes they agree over things. Like for example, if if they ask each other, okay, that do you like chocolate, and both of them say yes, and Evans by says that you know what, I like it 7. Like out of 10, I like it 7. That much I like it, and Evans Ben says 8. Okay, I'm getting too stuck up on the name. I can change the name. They're liking chocolate, man. Come on. I mean, it's not like he can eat chocolate. I think he's lying over here. Do you think this relationship is built on mistrust? Do you think he's making stuff up? We don't know. But for now, we'll take his word for it. Okay. He is saying that he likes chocolate this much. She's also saying she likes it this much. Okay. Then we ask them about vanilla ice cream. Okay. We're talking about ice cream, so chocolate ice cream. And he's like, okay, moderate, not that much. And she's also like, this much only, not that much. Okay. Okay. Mango also, they're like, yeah, they love it. Love it. Both of them love mango. Mango ice cream, both of them are crazy for it. So you can see here, we have this nice little graph over here, this like a table thingy, where you can see that he likes it this much and she likes it this much. Okay. So let's do one thing. Let's quickly get a mean, okay, an average of how much ice cream this guy likes and how much average ice cream this like. So this divided by 3 and same this divided by 3. So how much does Deviant by like it? On average, the ice cream, the different flavors of ice cream. Come on. This is for Devens by, right? 6.66 and 7.66. Okay. So on average, Devens Bank tends to like more ice creams. Like all the three flavors, she is liking it more. Okay. But now they have to do their job. What is their job? Does anyone remember what's their job? What is Devens Buy's job? He has to take each of the values that he likes and compares it to the average, right? That is his job, to classify X minus M. Same job she also has. Their colleagues. That's how the love started, They met in the office. So they have the same job. It's Jim and Bam all over. Yes, any office fans in the house. But you can see here that's their job. So let's put it here in this cute little table. Okay. So that we know that this is what their preferences are now, and they have to do their job also. Okay. So we'll see that Devensby's mean was 6.66 and her was 7 point what? 7.66. So now if we do that, what do we get? 7 minus, calculate 6.66. Help them do their job. 5 minus, this is minus, 6.66 and 8 minus 6.66. Same for Devensby. 8 minus 7.66. I'm just going to write mean over here so you understand. 6 minus m and 9 minus m. कितना आ रहा है? How much is it? -0.34 negative 1.66 and 1.34. ठीक है? And the other side? Same. How is that possible? Oh, for the first one. Oh, damn, it's same. Damn. 0.34, negative 1.66 and 1.34. Fine. So we'll put that here. Okay. 0.34, negative 1.66 and 1.34 and 0.34, negative 1.66 and 1.34. Now, our job here, okay, we are a little nosy. Okay, we want to see that, okay, these people are claiming that they like, these ice creams and stuff, but do they agree with each other on that? Do they agree that, okay, we both like this or we both don't like this? We are that, side में we're like, हाँ, इनका कुछ चल रहा है, लगता है, they might be a good couple, they might not be a good couple. So we are here to figure that out. So what we are going to do is, we are going to interact. Yeah, we're the Pados wali auntie. We want to see the interaction, like in a way, this, like this and this. And compatibility test. Yes, this is your compatibility test. What are that flames? Right? So we're doing kind of a flames thing situation over here for here. So we are seeing we're going to multiply these two. Okay. So 0.34 into 0.34. Because if this number is like positive, like if it's going higher, it means they're agreeing that, okay, compatible hai. Same we're going to do for the second and third. What do we get? 0.1156. ठीक है, next. 2.7556. Next. 1.7956. Right? Let me just cross check later. Zero point 0.11, 2.78. Okay, awesome. So now what we have to do is, okay, we're going to take these values because we are doing our flames test, no? We want to do something about it. We want to see that, okay, these guys have these values, no? That this is the agreement in a way that 0.1156, and we'll add them all up. Why? What do I want to do? I'll tell you. We're very, very nosy over here. We'll add the third one also. 1.7956, and we're going to take an average. So here it will be 3. So I want to see on average, is there the interaction, the compatibility going up for ice cream, or is it going down? One 1.7956. So what do we get when we add these up? Yeah, we get 1.556, which is greater than 0, which means on average these guys are agreeing, right? They're agreeing with their flavor of ice cream. They're agreeing with what they like with their preferences. That's a very cool thing. So now we'll do one thing. 36 good mil guy. Now we'll do one thing. We'll see a different scenario where in this scenario, Deviance Bhai is like, nah, I don't like it. I can't eat it. But mango, man, I love mango. I love it. Can I repeat the last part? The last part was just that you can see this. We got on average, we got this value, which is greater than 0, which means that their liking for ice cream is higher together. Together, both of them like ice cream quite a lot, the different flavors. If it was 0, it would mean that they're not like neither of them like, it may be Deviance Bhai doesn't like it and she likes it, like not that much. Okay. So here we are seeing that. So let's take another example here where Deviance Bhai likes it, likes the chocolate and vanilla part very little, but he loves mango. Whereas Deviance Bhai likes chocolate and vanilla, but hates mango, hates it. So let's do one thing. Let's calculate again. Now I'll let you guys do it this time. We're building to something. Don't worry. I'll tell you what. Now, when we're looking at Deviance Bhai's job, what do we get? So what is the first thing we have to do? Yes, you have to get them this, right? You have to get the mean first for both. How much they both like it. So what are we getting? Negative 3.33. But there's no negative value only. How are you getting negative? 3.33. Asaka. Okay. Dash. And for Deviance Bhai? Bhavi. 5.66. Okay. So now we come down and we'll let them do their job. We'll help them with their job. Okay. So Deviance Bhai was 3.33 and Deviance Bhai or Deviance Bhabi was 5.66 or 5.6. Either is fine. What do we get? Values are right here. It's 1 minus, no. It's the values, right? Yes, 1 minus, yes, for the first one, yes, correct. Is this for deviance by Khushi? Negative 2.33. Can someone cross check also? Negative 1.33 and 3.67. Okay, for deviance by? Okay. Hold on, we're cooking on something. We're cooking on to something very interesting. Two point three four, 0.34, and negative 2.66. Right. So now we're going to take that same thing and we're going to do the our multiplication thing, right? To see the compatibility test we're going to do now. We're going to do their flames. So what values we get? This is for the first one. This is for the first one. Okay. Negative 5.4522. Negative 0.4522. And the third one is negative 9.7622. So now what do we have to do? Take all of them and divide it by n. That is 3. Add all of them up. Right? 1, 2, and 3. Add them up. Divide by n. Negative 5 point. What is the correct value? Because I'm getting 2 answers. Can someone confirm? Yeah, it is negative 5.22. Yeah. So what is this? What have we done so far? What have we done so far? What do you guys think? What have we been doing? What have we reached? What have we calculated? Compatibility, maybe. But what are we looking for here? Similarities and their deviance, yes. So you can see here, right, in this group, the second one, right, it was negative 5.22, which means that even though, like, as her likes go up, his likes go down. Whereas for the first one, it was 1 point something, 1.5 something. So both their things were going up. What does this remind you of? Correlation, but correlation is not like negative 5. No, correlation is bound between negative 1 and 1. So what is this? Look at it as standard deviation, no. Chi-square, no. As his likes go up, hers goes down. As hers go up, his goes down in the second scenario. Whereas in the first one, as his goes up, hers also goes up. Regression, no. This is Why are we saying covariance? Co is just two, double. Variance is what we've looked at so far, right? As one thing goes up, other thing also goes up. If that is a positive covariance. As one thing goes up and another thing comes down, that's a negative covariance. And how are we figuring that out? We're taking deviance by, okay, we'll just put deviance by dB and deviance by n, or she's also dB, damn. Okay. BD, yeah, she's a baddie, yes. let's put BD here. And where interaction, looking at the interaction here, right? The multiplication of the two. Because if this is positive, the thing is positive, right? If this multiplication, this compatibility is positive, I end up getting this positive compatibility, this positive covariance. Yeah, cause two variances, yes. So this is what the covariance formula looks like. Right? This is what you've done. And you'll suddenly just like this, if I'd have just shown it to you, it would have seemed very scary, but right now you can recognize the people. Look at this. This is deviance by. This is deviance by divided by n. Now they put n minus 1 because of something known as Bessel's correction. I'll explain some other day. But for now, you just consider it as divided by n. But this is deviance by. So deviance by DDL. And we're seeing the multiplication between the two, and we're then adding that. That is covariance. Covariance of one variable with another. That's all it is. Yeah. But there's a problem. What's the problem? Does anyone know what's the problem over here with all of this? Degree of covariance. Yeah, degree. You can look at this. Yeah, no range, exactly. Like, okay, over here it says negative 5.22, but what do I make of it? It makes no sense to me. How do I interpret that? It's scale dependent, exactly. How do I make sense of this? It makes no sense. Let's say someone else also got 5.22, negative 5.22. Is this comparable? Probably not. It's dependent on the scale. Also, if I, like, let's say I am doing another covariance, okay? Once I do it with kilometers, but later then I do it with miles. These two will be different, the covariance values. So I need something that is stable, that is also interpretable. Because let's say I get a covariance of 1000, which is possible. What should I do with this? It makes no sense to me. Right? So that is the problem with covariance. This is the idea behind it, right? This is your group one. This is, oh wait, let me change my pencil. This is group one, this is group two, and this is deviances, right? This is the mean, the gray line is the mean, and this is how much is going up or down from the mean, correct? We've done this before, so the mean is here. So this is 2 points above the mean, this is 1 point below the mean, this is 2 points below the mean. Same over here too. The mean is kidhar? Yahan pe. The mean is here for the first one. And we are taking the deviations, like this deviation and this deviation, and we are multiplying them. Same over here too. This and multiply. So it ends up looking something like this. Again, scary looking, but same thing. We've done it. Deviance by divided by n for the average. So you can see here 0.4 into negative 3. We've done this before. See here 0.4 into negative 3. Not scary anymore. Exactly. You can see here then added by negative 1.4 into negative 2. Same. Negative 1.4 into negative 2. Then next would be negative 1.4 into negative 1. Why is it n minus 1? So I don't want to go into detail with this. When should we do n minus 1 and when should be n? So they tell you that when it is population, right, you should go with just n. When it's a sample, you should go with n minus 1. Why n minus 1? This is known as a correction. I won't go too much into detail to explain, but it's to correct it in case, the sample, because sample, right, might have errors, might have flaws, right? So it's to correct this minus 1, is to correct it so that the thing is not overestimating or underestimating. Okay. If you want to read more on vessels correction, I can send you some resources, but right now it's not important. For net and MPhil, this is all you need to remember. Maybe remember that it's called vessels correction, but beyond that, I don't have the time to explain all of it because we also have to do something else. Okay? I can send some resources and some good stuff on explaining properly vessels correction in terms of like overestimation and stuff. Okay? Yes. So this is what we have done so far. Same logic. You can see here. Then we added all of it up and we divided by n-1 or n, whatever, doesn't matter. And for this group also, they got the covariance value, which again means nothing. It tells me what? The magnitude or the strength? The magnitude or the direction? Magnitude here means strength. Okay. I'm not, it tells me the direction only. It tells me that it's a positive direction. But magnitude, I can't judge, right? If it's 4.25 and let's say someone else has 5.2, I know this is bigger, right? I know this is bigger, but by how much? Is that difference really meaningful? With correlation, we can do 0.2, 0.5, and 0.8. We say this is small. We say this is large. Sorry, what do you call it? Medium. And we call this large. But what do I call this? Do I call this small? Do I call this large? I don't know. Do I call this small? Ultra small then? I don't know. I can't compare it. I can't say that the magnitude is like, comparable. Right? So that is the problem over here with this, because what does it even mean? It means nothing. 4.25, what is it? Is it small? Is it big? Is it, I don't know. Which is why we end up standardizing it. Do you know what the standardization is called? What is the standardization called? Yes. This standardization is what we call correlation. Taking the covariance, right? And telling him, listen, you can only move from -1 till 1. If you try to step out of it, we will beat you. You cannot move outside of this range. You are stuck here. So covariance is taken and beaten into summation over here, that you have to be only here. You can't go out of it. So that is correlation. So how does that happen? We don't focus on variance. This is variance. But in a way, we also want it to make sense to us. We are focusing on variance. And this is then what we do with correlation. This is the formula for correlation. This is your covariance that we just got divided by the standard deviation of the first variable and the standard deviation of the second variable. Yeah, it can't give us much clarity on the direction. On the magnitude. It's telling me that, okay, it's positive, but it can't tell me on the magnitude that is this small, is this large? I can't really tell. So that's why we end up standardizing it into the correlation, which is taking the covariance and dividing it by what? The standard deviation of the first variable and standard deviation of the second variable. That's all. So take this example, right? What was our covariance? 5.22, no? Negative 5.22. So if I take this formula, I'll put it, I'm giving you the standard deviation over here. The first one is 3.21 and into 2.52. So what is the value? Negative 0.646. This is for our the ice cream example where Devins by likes one ice cream, he likes mango, but Devins by likes other ice creams. Now I can interpret this. I can say it's a moderate to large correlation. And I can say what? This is the magnitude, right? The strength in a way. And I can say the direction also, which is negative. Something we couldn't do with covariance. So does this make sense of how we just derived correlation? Now you'll never have to remember the formula ever again. Why? What is the formula? You have deviance by, you have deviance when, right? And we multiply them, we add them up, we take an average. And then what do? This guy is not giving me enough information. So what do I do then? I take him covariance and I divide by the standard deviation of both the two variables. And done. You have R. Simple, simple, scary, simple. Look at this. This looks scary. This looks scary. Kidhar hai? This formula. But now it does not. Doesn't make sense. Why do we divide by SD? It's in a way to restrict it between the ranges. Also, the standard deviation also is doing what it's telling you the how much is it deviating from the mean, right? So it's in a way restricting it. So that's a pretty cool thing that Pearson had figured out. So just look at the genius of Pearson to like come up with such a cool thing. So will you ever have to remember now the formula? Because now you just remember it. Now it's in your head. Now you know it. Okay. So simple. Was it so difficult? Was it any part of it difficult? Anything that wasn't very clear? Anything that felt like, "Arey, this is too hard"? Yeah, it's just multiplication, addition, subtraction, division. What I told you on day one. That's all you need to know. Okay. Now, quickly, we'll do the second thing. This is, I have a very hilarious example for it, and you want to love it. Okay. So, regression. What is regression? Does anyone know? Not Freudian wala. Predictor and causal. Hmm. It's related to probability, isn't everything? Okay. So let's say that there's this guy over here, okay? Alex. He wants to do something very simple. He wants to do a very simple task. Okay. He's this. Okay, firstly, let's say Alex looks good. Okay. Let's get this out of the way. He has the looks. He is on a dating app and he wants to do something simple. The bay cause. I throw you out. Okay. Yes. See, Kushi is getting what he's trying to do. He wants to predict the number of swipes he'll get on this dating app. Okay. This is right swipe. This is left swipe. If he puts a picture of him with a cat, you can see this cute little kitten. He wants to see that if there is a picture of his kitten, is he going to get swipes? And also, if you ever use your dating app, you know that this is a very common trick. Catfishing. Okay, that's a good one. I'll give you that. That's a very good one. This is a very common trick. People will just like bring a pet and they'll be like, "Hey, we'll use this for getting swipes." Okay, so he wants to predict the number of swipes he'll get. He wants to predict how many people will swipe on his picture. Okay, so what should he do? What should he try to do? What does he have to do first for this? Any guesses? What is the first thing he has to figure out? Okay, I'll give you a hint. Okay, the first thing he has to figure out is how many swipes he's going to get even without a cat. Yes, post one with cat and without cat. Yes, exactly. Without the cat, how zero? Damn, dude, he looks nice, man. Come on. Even though he's AI generated, we can say that he looks pretty good. Look at the jawline, dude. Look at the jawline. Cat. Okay. Okay. We want he too far. Why? What are your intentions? Long distance, man. Long distance. You start there. Come back to the point. He wants to see how many swipes is he even going to get without the cat. Without the cat, how many is he getting? And then he wants to see, secondly, that if he increases, how many swipes are increasing as he adds more and more pictures of cats. Okay. He wants to see, firstly, that if I add only a picture of me, how many swipes am I getting? And then if I add a picture of the cat, how many swipes am I getting? Because he's going to use this then to predict. Okay. So let's say that 4 swipes a day he gets on average when there is no cat. Okay, on average, in a day, he gets 4 swipes. 4 people give him a right swipe, which is honestly quite generous. Okay. And with cat, his swiping increases by 3. 3 swipes a day increase per cat picture. Per cat picture, his swipes increase by 3. So let's try to predict then how many swipes he's going to get as he puts more and more pictures of cats. So when there is no cat picture, like swipes, okay, 4 plus 3 into 0, right? This is the number of swipes he'll get per cat. And because there's 0 cats here, it's going to be 0 over here, right? So it's just going to be 4, which is what we already know, right? So let's do one thing. Let's add 1 cat picture. He's added 1 cat picture. Now how much is he going to get? 7. We're predicting, okay? We're predicting that he's going to get 7 swipes. 7 people are going to right swipe on him. Now let's say he adds 2 pictures of cats. How much can we predict he'll get in a day on average? 10. Okay, I'll write that over here. And 10. Why? 4 plus 3 into 2. So that's 4 plus 6. Right? This is the linear equation of regression. This is it. There's nothing more to it. This is it. This is the linear equation. So this is the swipes. This is the number of swipes you get when there is no cat picture. And then this is how many it's increasing per cat picture, and this is the unit, right? We had 1 or 0 cat pictures or 1 or 2 cat pictures. Yes. So this, you can see here, right? The first one, this is called the intercept. And what does it mean? Very simply, what is the value, right? Let's say with swipes, when there is no cat picture. Yes, it's coming back. What is the value when there is no cat picture? What is the value of swipes? How many swipes is he getting? Then we have the second thing, which is slope. What does the slope tell? That how much is it increasing by per unit? So as 1 unit increases, 1 unit of this guy increases, how much is the swipes increasing? That's it. That's all there is to it. And this is your independent variable. This was it. Let me give you a simpler example over here that you might use. I want to predict student anxiety using post satisfaction. So what am I doing? This is your Y, right? I want to predict P of anxiety. Kitna anxiety hai? How much anxiety do you have? Bahut sara, right? Lots and lots. So what do I have to do? I have to first collect. I have to see what is your anxiety level when your course satisfaction is 0. When you are not satisfied at all. So let's say we figure this out. We come to know that your anxiety when course satisfaction is 0 is 30. Okay, this is our intercept B0. Then we come to know that as your course satisfaction increasing, your anxiety decreases by -4. So this is your slope. So you can see here that, let's say we change it over here. Okay, let's say that your course satisfaction is 3. I'll change this to 3. What can I predict your anxiety as? If your course satisfaction is 3, it's not really like correlation. It's more like how much is this changing with 1 unit point. As my in this predictor variable is going up by 1 point, how much change am I seeing here? So you can see here it's 18. I'm predicting it is 18. Okay, what if the course satisfaction is 6? What can I predict the anxiety to be? 6. That's it. That's what regression is doing. Sometimes what we do is we also add an error term, right? This is the linear equation, right? B equals to B0, sorry, Y equals to B0 plus B1 X1, right? This is the intercept, slope, the IV, and we add an error term. Of course, I can repeat. I want to predict the anxiety using course satisfaction. That I want to see, is the anxiety increasing or decreasing as course satisfaction is increasing or decreasing. So I find out that your base rate of anxiety normally without any course satisfaction is 30. When your course satisfaction is 0, your anxiety is 30. And as your your core satisfaction goes up, let's say 1 point, or they give you a thing, right? How satisfied are you with this course on a scale of 0 to 10, right? Let's say you put a score of 4. So we do 30 plus -4 into 4, and then we do that math and we get the anxiety value. And the error term, very simply, is added here. The error term, no, is just like a check mark, right? Let's say I have predicted that when your course satisfaction score was what? At what did we get? 6. What did I say? What course satisfaction value did I say? Anyone remembers? 6 only. Okay. Wait, I'll tell you. Wait. So I am saying that when your course satisfaction is 6, your anxiety levels also should be 6. Then I find a student in the real world. Okay. He has given a course satisfaction of 6, but his anxiety is 31. Right? So then I am just checking the error, which is 31 minus 6, which is his score minus what I have predicted, and this is the error. 27. Yeah. So I know that if I'm getting this big an error, which means my model has something wrong with it, which means I need more and more predictors, which is why we end up having what? Multiple regression, right? So what is the multiple regression? Very simply just B2 X2 multiple. Same logic continues then. Now, why does this help predict? Because look at the logic, no? When you want to predict something, okay, in the future, what are you going to do? You are going to see what is the starting value, okay, starting value, and how much is it increasing, right? So if I want to predict someone's anxiety, I will see how much anxiety do you already have without me considering the increase. Then I will consider how much is it increasing. Same with the swipes. How many swipes are you getting normally, the starting value, with how much it's increasing. So that's how we are predicting. Does that make sense? So that is what makes it a predictor, that this guy is moving up by this much. And we're adding it with that, and that helps me predict. So where this value has come from. So what this -4 comes from is the software, right? It is basically trying to find the best possible line. This is what we call the slope, right? You might have learned. I won't go too much in the math. So it's trying to find the best possible line that fits it. It does it by itself. And it has found out that the slope is -4. The best possible line, ये line होता है ना? It's found out the best possible line is -4. For some other data, it might find that the best possible line is -2 or something, or just 5. We don't calculate it. The computer does it for us. They will never ask you to calculate the slope. Yes. But you understand the logic of what it's doing. So then when you go to your Jamovi, SPSS, R, whatever, you'll see right over there, the table for regression will contain the intercept. And then it will contain the name of your predictor variable. And it will say intercept is, let's say 36, which is, let's say, your anxiety scores. And then is your course satisfaction over here. And it says, okay, IV is, let's say, 4. Pretty much. Yes. So that is the very general idea of regression. And something as scary as this B0 plus B1 X1 is simple to understand. This is all it is. This is all what regression does. Does it make sense? This graph, what graph? So multiple regression, like what we were doing over here, right? Let's say with course satisfaction, I also want to see the number of hours you're sleeping. So what will I do? I will just add over here another thing, another variable. So it becomes the same thing. The computer will again give me the slope value, and I'll keep adding. Let's say it gave me 6, and I have added 1 hour of sleep. or I have added 4 hours of sleep, or I have added 6 hours of sleep. So that then gets added up to give me the final prediction value. So then I can keep adding more. Let's say this is my third variable. So this is the slope, right, into the third variable. So x3. Then I can keep adding more and more. B4, x4. Cute cat pictures. Yeah, you can. Yeah, cute bio plus cute cat pictures. Yeah, you can keep adding more and more. Exactly. See, the slope one was basically that when you're doing a this right regression, for example, you will have a scatter plot, right? This is the data. This is your correlation ka scatter plot. So it's trying to find the best possible line that fits all of it, and then it's like comparing like kitna distance hai from each point, like how much error. Yeah, the slopes keep varying based on your data, how good your data is. If your data is not good, if your data is very small and stuff, the slope will also be flawed. Okay, so is correlation and regression clear? Like I don't like expect you to get exactly how all of it functions, but I need you to understand the basic logic of it, the basic derivation. Because then when you are given like a question to interpret or to make sense of it, you can now do it. Or to predict also. Sometimes they do that. Then you can do it. It's very simple. Okay. Any questions? We're already past 8. No? No questions? Which prediction wala part? Oh, could you explain concept of error? Sure. 1 second. Which prediction wala part? Because all of it is prediction. The error very simply is checking how much is it differing in real life. Let's say I have, let me find a new place. Okay, wait. So yeah, okay. Let's say I have predicted that a student will have P of A, their anxiety. I'm predicting the anxiety scores will be 8 out of like whatever. Okay. I find out that in reality, their anxiety, wait, not P, just normally, their anxiety is actually much higher, let's say 12. So my model is then wrong, right? My prediction में थोड़ा error है. What is the error? The error is 12 minus 12 minus 8. So 4 points में error कर रहा है. It's underestimating a lot. I am underestimating his anxiety when his anxiety is much higher. So something is wrong with my model. This is a model, right? This whole thing, this equation that we have, it's a model. And I'm trying to predict his score. But I am seeing that people who have that much, whatever, the course satisfaction, their anxiety is coming out to be 12. So 4 points का average आ रहा है मुझे. So that is error. The one you write above, below multiple regression. Let me check. Oh, this part. So anything that you want to predict, how are you going to predict? You're going to see the starting point, right? Let's say I want to predict how much. I'm thinking of a good example. I want to predict how much Bollywood will earn if it makes 3 action movies. Okay, so what will I do? I will want to first see how much does Bollywood even earn in the first place. Then I'll want to do what? I want to then see that if I'm adding, let's say in the past, adding 2 Bollywood movies increased it by this much. So I will then use that to predict that this is equal to what it might be. So their income, their earning might be this month number, X number. That is the basic idea of how we do prediction, if you want to predict something. Or let's say, let's say simply, okay, you're trying to catch a train or you're trying to catch a flight. Okay, you are going to predict what that, okay, that plane is at 7 o'clock. But then you realize, let's say train that get delayed in Mumbai. But then you realize that it's actually raining. So what happens because of rain? You're going to assume that this is going to change. Because of the rain, the time is going to be delayed. Maybe the train will come at 7:15, delayed. So you're taking these different variables into account to predict. Okay. Makes sense, people? Correlation, covariance, regression. This is the basic idea of it. And I hope that at this point you'll also remember the formulas. Okay, awesome. I will see you guys tomorrow from 6 to 8 then. Okay. Bye bye. No, not today. I didn't get time to prepare it. Let me see if tomorrow I can do it. Yes, because the instructors are free from 6 to 8 only. Okay, bye bye. I'm ending the call.